For our final section of the day, we have two incredible panels and one final conversation. As you think about the afternoon, very often there's a moment where our attention starts to drift out to the things that have been waiting for us all day. So I invite you to just bring yourself back. See what you can learn from our final panelists, see what you can learn from these conversations. I like to imagine that at Sedai, they play the game Save the Best for Last. So this last section may or may not hold some of the greatest insights. For our panel this afternoon, Mo is online. Mo, are you there?
Yep.
Maybe.
I'm here. Can you hear me?
Excellent. Oh, I'm so delighted that you are here. Yeah. This final panel is called Can We Finally Defeat the Data Beast? Pipelines are bloated, warehouses are out of control, and Snowflake bills are making people sweat. In this panel, brilliant engineers share how they are fighting the data beast with smart automation and AI. So if your data platform feels more like a beast than a helpful tool, this session is designed to help you take back control. To facilitate this conversation, we're going to invite Rich Bentley up to the stage. He is our moderator. First and foremost, go Blue. No one else? Where is the love? Are you going to sing that though? Where is the love? And my voice is not good enough for that. My side hustle, my husband and I write books about marriage. And so as I was doing my homework about Rich, I was delighted to discover that he and his wife also collaborate on a project. Theirs, however, is called Love, Kill? Love, Marry, Kill. Marry in the middle. Love, Marry, Kill. If you want to know more about Rich, I highly recommend the podcast. It's very, very interesting. About 2/3 of the way through most episodes, I'm like, they did it. Obviously, they did it. It's kind of like a whodunit exploration. Fair?
Fair enough.
Okay. In his day job, Rich does all things marketing, previously at Dynatrace, and then now here at Sedai. And then also here, Roy. So Gaurav Roy, who goes by Roy, I'm just saying no one goes by their real names. It's like they're characters on the podcast. Slightly suspicious. Roy is an engineering leader at the crossroads of data, cloud, and services. He's the CTO at Excelia. Can I get a yeah?
Yeah.
Excelia. Tim laughed. He's been part of building industry-changing products, including, is it Tizen OS?
Yes, it runs all of your Samsung TVs. So if you're using a Samsung TV, fridge, or a watch, it's using my operating system.
Raise your hand if you have any of those things. Watch TV. No one else has a TV or a refrigerator? That's unbelievable. Amazing. And then Mo, welcome virtually. Mo is a cloud platform engineer at GSK, a biopharma company uniting science, technology, and talent to get ahead of lung diseases, oncology, HIV, and infectious diseases. Interests include big data, collaboration, social platform, and open source. Gentlemen, welcome to the stage. Thank you for joining us.
Thank you. Thank you for having us. Yeah.
Thank you. Thank you, Kaylee. And thank you, Roy and Mo, for joining us virtually for this panel discussion on taming the data beast. So as Kaylee mentioned, I do host a true crime podcast. We normally talk about murder. I'm not going to be talking about murder today, but I am going to be talking about a crime of another sort, and that is paying for cloud resources that you're not actually using, that you're wasting. And I think a lot of us have at least been a witness to that crime, if not a victim of that crime, when it comes to pipelines being bloated and your Databricks or your Snowflake bill going up month after month, becoming less and less predictable, architectures that are sprawling and chaotic. So I think between these two experts, we'll be able to kind of crack the code here. So I'm going to shift back to from a true crime analogy to a beast technology. So these guys have stared down the jaws of the beast and lived to tell the tale, which is really saying something because we had 4 people originally on the panel, and I think 2 of them did not live to tell the tale. So these 2 guys have survived. So thank you for being here. Let me start out by asking both of you to kind of describe what the data beast looks like in your world. I think every organization is a little bit different. Every organization has its own set of challenges. So Mo, why don't I start with you virtually? And if you were to describe the data beast, how would you characterize it?
Yeah, great. Thanks for having me, first of all. So I'll start in a nice. So if you had asked me the same question about 5-6 years ago when we started the journey on the cloud, it would have been a very centralized beast. But over time, we figured out very quickly that the better option for us would be a decentralized option. It's a data mesh architecture. So where the data platform is owned by one team, but the data domain architects, so the data domain product owners run their own team. So I would say we are a collaborative team coming together like a pack. And as I'm in Raleigh, North Carolina, the piece that I'll think about ourselves is like a wolf pack, where we come in, we consolidate, we collaborate, we think about everything from security, risk posture, cost optimization, compliance, because we're a big compliance company. So in short, what I would describe ourselves as a wolf pack from a beast perspective, Richard. So that's how I would look at it.
Gotcha. Roy, how about you?
Yeah, firstly, I didn't sign up to be interrogated by an interrogator here. True crime and all that. Very interesting. Hey, so when I think of data platforms, right, a particular animal comes to mind that is very synonymous with Sedai. It's the octopus.
The octopus, yeah.
And why I think of it in this particular way is because of this reason. Uh, how you think of data platforms is in this way. Just like the limbs of the octopus, you're getting amazing amount of data signals of varied types, and you're bringing it into a central brain to process and give insights that are going to drive real ROI. And that's what the mission is. So everything should be tuned towards fast data processing, uh, as well as capture, and then actually spewing out insights in a very, very clear fashion.
Yeah, that's a great analogy. And I learned on my Uber ride over here yesterday that octopuses actually have multiple brains as well. So there's a lot going on there. What I'm curious, like in your environments, what makes your particular data beast unique or different than maybe other organizations? So I don't know, Roy, if you want to start that one out.
Each one is very different, and I'll take a bit of Paul's thunder here too. So before this, I was a customer with Sedai with HP. Now I've moved to Excelia. They are two different sorts of organizations. So when you look at a data beast or any particular cloud infrastructure, there are three things that become your first bottleneck. I think somebody else had mentioned this. It could be compute, it could be storage, or it could be networking. In most cases, it's always compute, basically, which drives the most amount of cost. This is true for Excelia. We serve 40 billion offers every day. That means across 40 plus airlines. So whether you're flying on a Hawaiian to a Qantas, and you're searching a ticket on a private thing like Expedia or a SAP Concur, it's hitting our API. So 40 billion of them. And each one of them, say, imagine you're going from San Francisco to Houston or San Francisco to Johannesburg. It's like 20,000 routes with 20,000 legs, and we are computing that within 2 seconds. Insane amount of data and compute load. So our compute costs are obviously very high. It's close to like 58.4% is basically just compute. Our data is around 10%. Our other services networking is like 7%. If you go to some other company, say like HP, it will be completely reverse. There, my main system was primarily data analytics, where the data infrastructure and storage and all of those Snowflake and other things were like 66% plus. So it differs based upon your this thing, and it's very, very varied. But most will be on the tune of Excelia. So I would say we are not very different. We are similar with unique problems in the airline space versus being exception.
Yeah, it's a lot of data and a lot of speed required as well. Mo, how about you? What makes your the situation at GSK kind of unique in terms of your data?
So within GSK, so there are two kinds of data platform we have, right? Again, we being a pharma company, we have a research data platform which is more flexible, right? Which is hosted on Google Cloud Platform, which is called Onyx internally, but it's a complete research data platform, and its primarily our task is to, as the gentleman here was talking about, right, is for us is to take the thousands of target molecules, 100,000 target molecules, and get to our target molecule, what we call in silico discovery, right? So we want to discover medicines very quickly. So that's one data platform. And then once the molecule, the target molecule gets discovered, then we are talking about all operational stuff, and we call this another data platform which sits in Code Orange. So the good thing is we have two centralized data platforms, things are going on. And as the gentleman was mentioning, as we start on a cloud journey, our two cloud providers are Azure and GCP, and all our data platforms are built on this. Predominantly are, again, same business value. We got good business value and stuff like that, better quality and stuff like that, right? But the biggest challenge for us, where as the gentleman was talking about, is compute cost. I can talk about the journey of how we started with a large scale. I think we could be one of the biggest Databricks cluster built. I think about 200 plus Databricks cluster, which spans across our two platforms. Compute cost, storage cost, user sprawl. A lot of notebooks were written. Like people just write notebooks periodically, so there are a lot of user sprawl that people could just write notebooks around, so on and so forth. Insufficient queries. The queries, right? How people write the queries. If there's a large storage, then the query performance becomes majority of issues. So the inefficient queries that were being written. Things like observability. How do we drive good observability so that you could get alerted from cost issues or performance issues? The whole ETL process, right? You extract, transform, and load, and the ingestion pipelines, right? So there's a lot of tool proliferation. Like each of the teams are using their own tools. How do we centralize the tooling, and how do we govern those tools? That was another big thing. Weak governance, as usual, was another big element where we started taming the beast, right? So these are all the key elements for us from a problem statement when we started looking. As I said, initially the data platforms are all over the place. We centralized the data platform, and these are some of the key elements that we were targeting to tame the beast, for lack of a better word. Yeah.
Yeah, great. Let me ask about the origin story of the beast in both of your environments. So how do platforms like Databricks or Snowflake or whatever you're using to manage your data, how do they get out of control in the first place? What do you see as being kind of the core reasons for some of the challenges that you have? Mo, I'll start with you on this one.
So as I mentioned initially, when we started on the cloud journey, right, there was not much of governance. And what happens is when the data owners, remember the data domain owners, they could go build their own Databricks clusters. And as they bring Databricks clusters, there's an educations, right? And even the Databricks as a platform also started evolving, right? Initially, if you take a look at Databricks history, they were all-purpose clusters. You have to bring up clusters. There was nothing like auto termination of clusters. There was nothing. Auto scaling of clusters were a little bit minimal. But those were some of the big things. And again, they were stirring storage in, right? For example, if you take a look at the amount of storage that we have currently, right? How much amount of that raw data is still around and not being deleted, right? Those are some of the bigger issues that when we start on the platform, these are some of the key pain points and things like, as I was mentioned, right? Things like monitoring and logging, FinOps perspective. How do we drive CI/CD for tool pipelines? You name it, we hit almost every element from a platform perspective for the past 3-4 years. And as I said, now things have changed. Now another key thing that we did, again, just talking about the solution, I'm not talking about the solution, but just talking about it, is when you talk about the data platform itself, right? The data platform itself cannot be an infrastructure, right? It's a platform. It has to be owned by one. That's another thing. But the data products that are being built, they should have good ownership of it, right? If they have good ownership, and if you tag the data pretty much well, which wasn't done before, if you start tagging the infrastructure and the data platform properly, then the data owners by themselves start governing pretty well, as long as they do a good show back and a good charge back. And as we talk about within this meeting, along this presentation, I can talk to you about how giving more responsibility also to the data owners help resolve a lot of some issues. But currently the same thing, as I said, a lot of things, and slowly and steadily, we ran into every problem that you can talk about: compute, user, insufficient queries, I talked about. Yeah.
Yeah. So a lot of flexibility. It's easy to use. You want to empower people to do their jobs, but at the same time, that can cause things to become out of control.
Yeah, governance is the biggest issue. Yeah.
Yeah. How about you, Ray?
Yeah, a very, very interesting take more on the empowered governance, is what I'll call that. Anyways, on coming back to how the problem really multiplies, right? Uh, I have faced it in two halves. You can say one is compute, and one is data. I've never faced it on networking, so I don't have any experience on that. On compute, what happens is that you give autonomy. People go and create clusters. They create their own queries. These queries become super complex over time. They are duplicated. Insane amount of compute goes away. Secondly is data. You start collecting data. It starts off very small. You're just saving it in S3. You're saving it in Redshift. There's no cost. Come in a year, you've collected truckloads of data without any data lineage, without any data ownership. It's a data swamp. And along with that, because you save it in Parquet files like this, your compute costs also multiply as you have to plow through all of the data to find the right data set. This is extremely complex. When we started off, and I think not in this organization, in the previous one that I worked in, it was like every 3-4 months, I would get a bill shock from AWS. Oh man, it expanded multi-X. And why? Okay, compute's gone rogue, data's gone rogue, clean up, bring it back. But it needs to be much more autonomous. The guardrails that Mo's talking about, the only long-term way is to reduce human lethargy or not the urge not to do repeated toil is to basically go towards autonomous tasks.
Yeah.
And guardrails. Yeah.
Well, we would not disagree with that. I love the term data swamp. we,
Yeah.
we have data lakes, we have data warehouses, data lake houses, but data swamp is it's a really good visual metaphor. I like that. How would you, like, you talked about it a little bit, Roy, but how would you say what would you say is the difference between managing and optimizing data platforms versus optimizing, VMs and containers and things like that? What are the unique things is it more challenging on the data side, would you say?
It's not as evolved. So telemetry is not as strong as CAPMs, right? Like what Tim was challenging everybody on CAPMs. They have not evolved to the same extent on the data side. So that's a major challenge that any one of us really faces. But the problems remain the same. Like you heard it from Suresh in the opening this thing itself. GPU, CPU is very similar. So you got to attack based upon your weakest point of infrastructure in terms of cost or scaling. What basically fills up first, whether it's CPU, storage, or networking in terms of cost, and basically scale accordingly. Yeah.
Yeah, makes sense. How about Mo? Any additional thoughts on kind of the differences?
No, I think nailed it, right? So if you talk about plain old, at the end of the day, we tackle the same compute cost, and the way we attack compute costs or the storage costs and networking is typically when you have a lot of data movements, there's an egress cost. I think that's basically what hits us a lot, especially if you start moving data between regions. So how do you architect the data platform is highly important so that you don't move data back and forth. So all those three are the key same elements, whether you talk about containers, whether you talk about virtual machines, and yeah, so absolutely exactly the same thing. And as I said, the data, if you keep moving, if you start trunking a lot of, I think the bigger challenge with the containers, virtual machines, you don't manipulate large sets of data. The only biggest thing here is now you're talking about large data sets and stuff like that. And how do you manage it? How do you start doing retention policies and stuff like that? I think that's the biggest element beyond just the compute part of it from our case. Yeah.
Yeah, makes sense. So we talked, Roy, you talked a little bit about the need to become autonomous. I think as we learned this morning, being automated is very different from being autonomous, but automation can help, right? As a starting point. Is there, when you look at your data stack, is there a place for automation? Is there a place that you would target automation first as kind of a starting point to help with some of these issues?
Yes. So if you are targeting, I think there was a lot of FinOps here, right? So if you are targeting mainly the cost problem, which is very big on the data side, firstly, you got to do an assessment of which are the most flaky parts of your infrastructure or the parts of the infrastructure that suddenly go wild in terms of costs. You got to, which is happening repeatedly, figure out guardrails for the same. That's step one. Step two is you should be able to automate those guardrails. That example, if you are running a cluster for more than 24 hours as a developer, either directly kill it or throw an alert to somebody in DevOps to basically go and kill it. Same in the case of data. Thirdly, if FinOps is not automated and it's manual, it's dead, essentially. It humans just don't do it every 2-3 months. Maybe in the month of December, your people are on leave, they're just going to disappear, essentially. So it doesn't work quarter on quarter. So I would say the three, like go and assess, build guardrails, also build up FinOps dashboards that track your data and alert you in a real sense. With that, your teams will really fly. This autonomy is going to increase their throughput multifold as the toil is removed from their life.
Yeah. Anything to add to that, Mo?
Yeah, I'll talk about autonomous. I'll talk about autonomous later, right? Because with autonomous also comes a few challenges, right? And things like that, like how mature is the autonomous model. So I'll take Databricks as a classic example. Today we challenge our data developers, right? Typically, why are you running? So in Databricks, there are two options. As I said, there's all-purpose clusters, and there's called job clusters. Job clusters automatically terminate, while all-purpose clusters are manually need to be terminated. So if I have to use a FinOps tool, I have to manually say, hey, things are. In the case of job clusters, you finish a job, it gets terminated. So that's our first automation. We just said, hey, you don't have to do much. Take a look at your jobs. If you're just doing plain old ETL, extract, transform, load, start using job clusters within Databricks. So that definitely helps. Turn on your auto termination clusters, right? Auto termination clusters, there's something called idle timeout. By default is 60 minutes. Bring it down to 30, bring it out to an asset. Start looking at all those elements and start automating those principles. And as you bring Databricks clusters, when you bring up Databricks clusters, make sure that this configuration goes automatically. So those are one of the key things. But another most important thing for us is how do we, to reach the FinOps, the tooling perspective, right? The one thing that we've done from an automation perspective is very important is we tag all our resources specific to the business unit, the business functions, the data domain product owner stuff. So everyone knows who it is, and they all get reports every month to see what the cost factor is. Kid you not, we actually run a FinOps forum now in-house, I think twice a week. And one of the biggest conversation 2 weeks ago was about Databricks. And it was really surprising to see people have started, within GSK, within our organization, people have started doing job clusters. They're doing very good decisions on job clusters. They're very good in auto scaling, terminating things like Power BI workloads, which are used to visualize. Rather than using Databricks clusters, they started using data warehouses which has more optimized approach of caching and stuff like that. So there are a lot of good things that can be done. As I said, you have to peel the onion one by one. But the first thing for anything is tag your resources, figure out your observability, figure out your cost element per month, then start figuring out what your attack vectors are. As I said, each of the technology that you're using do have capability. It's just how you educate the people around you to make use of those resources. That's how we started tackling the project. As I said, it's been a 4-year journey, and it continues to be a very big journey for us to optimize cost down to a level, because budgets are not immense. There's only a specific amount of budgets, and you have to stick to that budget because that's what you signed your contract with the providers. So for us, cost efficiency was important, right? If we can get to autonomous, that'll be amazing for us. That'll be the next step that we're hopefully working with Sedai to say, okay, I have my Databricks. What more can you tweak for me so I can become very autonomous? Can I get autonomous? So right now we're in the process of good decision making by our end users, by our business users.
Yeah. Oh, that's great advice. I love. There's the saying. I think we've all heard it. With culture eats strategy for breakfast, right? And it sounds like you're taking that approach, right? You're trying to establish the right culture, and then the rest will follow from that. So that's great. We're quickly running out of time. This has been really great. I want to ask one more question, but then I want to leave time for our audience to ask a question or two of you guys. So my last question, and you may have covered it a little bit already, but if you had to name kind of the single most effective strategy that you've found for managing your data platforms and bringing down the data beast for good, what would you say is that strategy? So Roy, I'll start with you.
This is one thing that came up in our roundtable conversation. It's not exactly a strategy, but it's applicable everywhere. You require to look at ROI. Your data platform is driving customer value. That should be quantifiable. You heard that from Joel, where he said he could easily get funding when he showed the revenue of kiosks and various other things. either it needs to drive top line revenue or it needs to reduce costs. And that's basically the incentive on the thing. Just focus on that, everything will fall in line.
Love it. Mo?
Yeah, same thing, but in a different way, I'll say. If you look at data as a product, then as he said, it's all about return of investment. Is the data product really helpful to help our business? That's all. We wanted to change the paradigm shift. It's not infrastructure. Look at it as a product. If you look at the data platform as a product, if you look at the data domain as a product, then the ROIs come in properly, efficiencies come in properly. So that's how I echo the same thing, but in a different way. That's about it. Yeah.
Great. Thank you so much. What questions do we have for Mo and Roy? I see one out there.
Actually, a question with a perspective. I see from my understanding, GSK has data in-house, whereas Excelia has data dependency. I mean, when you mentioned that majority of your costs are with compute, 50% plus and 10 on data and 10 plus around networking, right? It's a perspective, I guess, like, for example, compute, right? Especially with cloud like AWS or Azure.
Yeah.
So if you take EC2, you choose the type of instance, it also deals with the network IO bandwidth, right? So
Correct.
as Mo mentioned earlier, the data in and out also matters. So if you have more dependency on external systems rather than internal systems for your data, so maybe that is also driving costs. So it looks like it's the actual EC2. Maybe that's where
Yes.
AI could,
Yeah, SSN. Yes. I've been like 6-8 months in Excelia. So I've looked at it in a little bit more of detail. What you say could have been a good theory, but it's not actually in practice. I'll explain you the EC2 workload a little bit, and this is going to get a little more geekier side for most of the engineers. We have all of the data in our system. We actually cache it from airlines. We cache it from third-party non-profits in the airline industry. Like, you get all your schedules from Online Aviation Group. You get all your fare rules from Airline Tariff Publishing Corporation. Our challenge, where it becomes a compute challenge, is mainly the huge volume of data. Imagine you have got somewhere around 100 active airlines. Each of them average maybe like 200, 300 planes, each flying non-stop. And when you're going multi-route, it becomes like, you're that graph problems in traditional computer science, and you're computing them with multiple segments on all the 26 classes to find prices, and you have to do that within 2 seconds. So that's basically where it becomes super compute intensive. It got so compute intensive for us that we got to load all of that data into memory, and we use actually shared memory. That's why our data dependence reduces a lot, because of our performance needs, where we operate a lot of this graph traversal in memory. And that takes practically like 50% of our, if I'm saying that 58, 60% is our CPU usage on AWS, 50% of it is just that. So I think that generally answers your question, right? That why we are not that dependent upon thrashing data. But certainly our analytical systems, and as we are doing more of the AI stuff, we expect a lot more data load on both Snowflake and AWS clusters. Yeah. Great question, Assistant. Yeah.
Awesome. Thank you. All right, we'll take one more question, and then I know we're over.
Yeah.
Thanks. You've been talking a lot about compute. So one of the things I hear a lot about when it comes to Databricks from companies is they cannot stand when they use SQL compute and they have to figure out DBU consumption or Databricks unit consumption. So they're running some kind of serverless environment. And it tends to be more for the SQL compute than the jobs compute. And I'm just curious, how have you approached that, and what has been your strategy for tackling those DBU costs when you don't know what kind of instance is sitting behind them?
In the last one, so currently we use Databricks a lot lesser. In one of my previous companies, we did. It went to that much extent that we had to move to EMR. At some place, the DBU. See, when we started off in that journey, Databricks was way ahead, and EMR started catching up. So for the needs that we had, EMR was sufficient. Used to run close to like 250 different types of jobs, and we moved a lot of them, the high compute ones, over to EMR. So, but there needs to be a better strategy. I understand. You can't be cheating like me all the time. Yes, I think GSK maybe. Are you all more on Databricks more, or
Yeah, we are a big
Yeah.
Databricks shop.
would you like to take
And-
that question? Yeah.
Yeah, sure. So your question is about serverless, right? So as I
Yeah.
said, serverless cluster and the DB units, right? So that become definitely cost. So which is why I was talking about things like serverless clusters are basically all-purpose clusters, right? And so that's the reason why I was talking about, hey, do you really need that? Do you really have to do that? Can you use job clusters, which terminates and which has lower costs and stuff like that? That's why I was talking about that aspect of it. So we run into the same problem for serverless. So we reduce the number of serverless compute that we need and get into more of the job clusters aspect of it.
Awesome. Well, thank you both so much. Roy, appreciate your insights. Mo, appreciate you joining virtually and sharing your insights. Hopefully this has inspired all of you to go and defeat the data beast in your own environment. So thank you.
Thank you.
Thank you.